Okay, we're going to continue this and look at how do we handle binomials in the denominator. So what we need to do is we have to think about the difference of squares and the sum and difference relationship between a difference of squares and its factors. So we know that this equals this and vice versa, right? So if we can get to a situation where we can get a difference of squares, what we can do is we can get rid of the square root here, the root 5, because if I square the first term 1, and I square this, I'm going to get rid of the root 5, which is what we want to do for the denominator. So if we think of sum and difference, we can do that. So this is really a sum. If we multiply by the difference of those two terms, then you can get a difference of squares scenario, which is called the conjugate. So this is our denominator. Its conjugate is its opposite. So if it's 1 plus 3 root 5, then it's 1 minus 3 root 5. And the other way around would be, if this was 1 minus 3 root 5, we would multiply by 1 plus 3 root 5. Sum and difference, or difference and sum, doesn't matter. Difference of squares is our target. So this is what we do. We multiply both numerator and the denominator, in this case by the subtraction of 1 minus 3 root 5. Notice that we're not breaking any rules because we're dividing or multiplying by essentially 1, right? This divided by this is 1, no big deal. So again, we just simply have to expand this. 4 minus 12 root 5 over, okay, we know that this is a sum and difference, so this becomes a difference of squares. So the square of this is 1, and the square of this is, well, what's 3 root 5 times 3 root 5? 3 root 5 times 3 root 5 is like 9 times 5. Root 5 times root 5 is 5, which works out to be 4 minus 12 root 5 over 9 times 5 is 45. So 1 minus 45 is 44, and we can simplify that by dividing by 4. So we'll divide everything by 4, and we're left with 1 minus 3 root 5 over 11. Okay, right. So notice that by multiplying by its conjugate, we get a sum and difference, which turns into a difference of squares, which allows us to take the square of the first term, which is 1, and the square of the second radical, 3 root 5, which is 9 times 5. Why? Because the root of 5 times the root of 5 is 5. I'll show it quickly over here. Again, the square of 3 root 5 is equal to 3 root 5 times 3 root 5, which is 9 times, well, root 5 times root 5 is 5, which is 45. Okay? So that's why the difference of squares method works. All right. Same thing goes over here. So we've got 2 plus 3 root 3. We've got to get rid of that. It's radical by multiplying by its conjugate, which is 4 minus root 2, 2 plus 3 root 3 times 2 minus 3 root 3 over 2 minus 3 root 3. Notice that's still 1. We're not violating any weird rules here, but we're multiplying by its conjugate, which will turn into a difference of squares. And I'll show it slightly differently. We end up having a binomial multiplication here, fair enough. So we've got 4 times 2 is 8. Minus 12 root 6. Sorry, root 3. And then we've got minus 2 root 2. And then plus 3 root 6. Okay. All over. I'm going to show it as a difference of squares just so you can see what I mean. 2 squared minus 3 root 3 squared. See that? Sum and difference of squares, right? And you end up with 8 minus 12 root 3 minus 2 root 2 plus 3 sorry, that should have been 3 root 6. 3 root 6 all over 4 minus 3 squared is 9 times root 3, which is really 3. 3 times 9 is 27, which equals 8 minus 12 root 3 minus 2 root 2 plus 3 root 6 all over negative 23. Bring the negative up, and we're left with negative 8 plus 12 root 3 minus 2 root 2 minus 3 root 6 all over 23. Sorry about that. Ran out of space. Okay. So that's how we do it. The key is when we're conjugating and trying to rationalize the denominator, and you're finding the conjugate, it really stems from this principle of our difference of squares. A squared minus b squared is a plus b times a minus b, or a minus b times a plus b, doesn't matter, and vice versa. So they can both ways. If we do this, we can turn it into a difference of squares, which allows us to get rid of the radical in the denominator.